All right, today we're going to be going over graphing inequalities of linear functions. So the first couple we're going to talk about are just whether you have a vertical or a horizontal line, and then we're going to talk about what it means to be greater than or less than that value. So if you look at this first one, for example, it says x is greater than negative 2. Now you can think about all the x values that would be greater than negative 2. Is negative 1 greater than negative 2? Is 0? Is negative 5 greater than negative 2? Is 5 greater than negative 2? Is 3 greater than negative 2? Is negative 3 greater than negative 2? You can ask yourself those questions. You can kind of have a general idea of what this is going to look like and entail. But on a graph, as a line, it's going to look a little different. So first of all, you want to make sure you have your x and your y axis. Remember, the x-axis is your horizontal axis, and your y-axis is your vertical axis. Now, x would normally be equal to negative 2. So where would x be normally equal to negative 2? Where is the x value going to be negative 2? On the x-axis at negative 2. So that's the first thing you want to do is mark that point. And then all x equals values will be vertical lines, because these x values are always negative 2. For example, this is negative 2, 0. Up here might be negative 2, say 4. Down here might be negative 2, say negative 3 or something. But all these values are negative 2. So this is my line. Now, here's what I want to do. Because there is no equal sign under here, I want to dot this. So I'm going to show a dotted just by putting some dashes through here. But normally you would want to actually dot the line at negative 2. So I would draw a dotted line at x equals negative 2. Then I would say which values are greater than that negative 2. Which values are greater than negative 2? The ones to the right or the left compared to this line? They would be to the right. So I shade this area. That's it. Or if I was doing this one, I'd shade that area. That's it. Okay. Number 2. What value should I mark on the x-axis? Obviously 5. Now, I'm going to again have a horizontal line there. This one is not dotted because it's equal to. Now, where should I shade? X is what? Greater than or less than 5? X is less than or equal to 5. So less than is to the left. So all this area is shaded. Again, would negative 1 work? Yes. Would 1 work? Yes. Would 4 work? Yes. Would 4.999 work? Yes. Would 5.001 work? No. Anything to the right of 5 is not going to work. Okay? Now we're going to go to a y value with no x value. So if there's a y with no x, so when there was an x with no y, like on the previous two, we had vertical lines. So a y with no x, what type of line are we going to have? Exactly, a horizontal line. So if this is the x-axis, this is the y-axis, I want to mark y equaling negative 1. So that's where on the y-axis we'd have negative 1. It's equal to, so I'm going to make it solid, not shaded in. And y is greater than. So usually, on almost all of them, unless there's no y, unless there's only an x, we're going to ask ourselves the question, should we shade above or below the line? Well, if y is greater than, are the y's above the line greater than negative 1? Or are the y's below the line greater than negative 1? Well, obviously 0, 1, 2, 3, 4, 5, 10 million, whatever. Those are all greater than negative 1, so we're going to shade above. And that's the answer. Okay. Now let's look at number 4. Here we have both an x and a y. How are we going to graph this? Which variable do we need to get by itself? Right, we want to get the y by itself. Okay, so again, treat this greater than, less than as if it was an equal sign. I just want to get the y by itself on the left side of this greater than, less than sign. So I'm going to start out by getting rid of the x part to the other side, minusing 2x. That leaves 3y. Don't change this when you subtract. Only change it if you divide by a negative. That's something you might want to write in your notes. Only change the sign of the inequality if you divide or multiply by a negative value. And here we're just subtracting. That's not dividing or multiplying by a negative value. So therefore I leave the inequality alone. Leave it as less than. So 3y is less than negative 2x. Always put the x part first. Minus 9. Then follow it with whatever the numeric value is without the variable part, or the constant value, as we call it. So I'm going to divide both sides by 3. Again, goal is to get this y by itself. Again, I haven't divided by a negative value. Make sure you divide both terms by 3. So the negative 2 and the 3 do not reduce, so I'm going to leave it as negative 2 over 3x, because that did not reduce. But here I'm going to have 9 divided by 3. What's 9 divided by 3? Exactly, it's 3. So I'm going to have a negative divided by a positive is a negative 3. A negative 2 divided by a 3 is a negative 2/3. That's good, though, because that's going to be how I want my graph to look anyway. What does this part in front of the x represent? What does the constant, or the number that follows the x, represent on my graph? Exactly. This negative 3 is the key starting point. That's where I'm going to start on the y-axis. This is my y-intercept. The y-intercept is negative 3, so I'm going to start down on the y-axis. Remember, this is the y, this is the x, at negative 3. Mark that point. From that point, don't start at 0, 0. Don't start at any other points. At this point of negative 3, follow the slope. The slope is always the rise or fall over the run. So I'm going to fall to, or go down to, and to the right, or in a positive direction, 3. So I'm going to go down 2 and right 3. From that point of negative 3. Down 2 over 3. I can keep doing that. I can go from this new point, which is really at 3, negative 5. I can go from 3, negative 5 down 2 more and over 3 more. Now I'm really at 6 and negative 7. And those all connect. Notice if my slope is negative, which it is, it should go down to the right. Now, I should have done what here? What did I forget to do? I should have dotted it. So again, I'm just going to make some dashes through there indicating that this is dotted. And that means it's not equal to the line. It gets close to it, but it never will equal it. And then I want to shade it either above or below. And you always compare the y. So the y's should be less than the line. That's how you read that. The y's should be less than the line. So thinking about the line, where are the y values, the y-axis, where are the y values less than this line? It's going to shade below. Kind of on a slant, but it's shading below the line. And that's my answer. Now, if you want to check your shading, pick a point that's below the line. So let's say I came down here at 0, negative 5. Notice 0, negative 5 is right here in this shaded area. 0, negative 5. Let's plug that in and see if it would work. So if the y is negative 5 and the x is 0, so that would 0, would negative 5, and then that's 0 minus 3. So therefore, would negative 5 be less than negative 3? Is that true? It is. And if it's true, then I've shaded the right area. Okay, let's try number 5. Again, what's the first step? I want to be able to graph this line. What should I do first? Get the y by itself. So I'm going to subtract the 3x. Have I divided by a negative? No, subtracting is not dividing by a negative. So I have negative 2y less than or equal to negative 3x plus 8. Again, put the x part in front of the constant part. Now what should I divide by? Negative 2. Now, am I dividing by a negative value? Yes. If you divide by a negative, you must flip the sign of the inequality. So therefore, I'm going to have greater than or equal to a negative divided by a negative is a positive 3/2 x, and a positive divided by a negative is a negative 4. So now I'm ready to graph. Where should I start? Negative 4 on the y-axis. And where should I go from there? Up 3 over 2. Up 3. Remember, the axis counts as 1, 2, 3 over 2. So this one is going up 3 and over 2. Now, here's my line. It is equal to, so I don't have to dash it. And now it's got to be greater than y. Always read from the y, not the x. Y is greater than or equal to the line. Where is y greater than the line? Above or below? You should always ask yourself, even if it's slanted, if it's above or below the line. So this should be shaded above. Now there's a real easy point here. 0, 0 is in that shaded area. Let's put in 0 for both. Is 0 greater than or equal to? That would be a 0. Negative 4. Is that true? Yep. And it works. So I picked the point 0, 0 because it was in the shaded area. Okay, you can pick any point you want that's in the shaded area. I just picked the ones that are easy. All right. Now, sometimes you're going to get questions like number 6, which simply give you the equation, and they ask you questions about whether the points represent a solution for the equation. In this case, you don't have to graph it, so you don't have to graph the equation. You don't have to solve for y. You just substitute in these values for x and y. So let's do that and see if this is a solution. So this one I'm going to have 3 times the x value is negative 2, and the y value is 3. Will that be true or false? 3 times negative 2 is negative 6. 4 times positive 3 is 12. Negative 6 plus 12 is positive 6. Positive 6. Is that greater than or equal to 2? Is that true? Yes, it's true. So yes, that's a solution. And this shows my work as to how I know it's a solution. Let's try this other point and see if it's going to be a solution. Again, just sub it in for x and y. 3 is the x, negative 2 is the y. So I have 3 times 3 plus 4 times negative 2. That should be greater than or equal to 2. Let's see if it is. 3 times 3 is 9. 4 times negative 2, positive times negative, is a negative. 4 times 2 is 8. What's 9 minus 8? That's going to be 1. Is 1 greater than or equal to 2? Is 1 greater than 2? No. No. False. So this would be a no or a false. This would be a yes or a true. And that's how we know whether those are solutions. Okay, I want you to do in your book, set 5.6 in the green book. You're going to do problems 1 through 19. Kate will help you with 19. Thank you. Bye.